Hello everyone, in today's video I'll explain about transport number. So what do we mean by the transport number? So we know when we take an electrolyte, when we are adding that electrolyte to water, it dissociates into different ions, namely cation and anion. So when we pass electrolyte by putting electrodes like cathode and anode, what happens? These ions carries electricity. The fraction of total current carried by these ions is called transport number. Okay, the fraction is the total amount of the current carried by these ions is called transport number. So transport number is exhibited for both ions here. So if we exhibit for cation, it is represented with T plus or TC, transport number of positive ion or transport number of cation. If we represent for anions, it is represented with T minus or Ta. T minus means transport number of negative ion or transport number of anion. Okay, the total current carried by these ions is directly proportional to the speeds of the ions. So mu plus and mu minus are nothing but speed of cation and speed of anion. Okay, so now T plus that means we can calculate the transport number of positive ion by using this formula. Current carried by the cation by total current carried by these ions. So current carried by the ions is directly proportional to the mu plus cation, means we represent with mu plus speed of the cation by total speed of the electron. So total current carried by the ions, mu plus and mu minus. So transport number of positive ion can be calculated by using this formula. Speed of positive ion by speed of the total ions present in the given solution. Okay. Now let us see the transport number of anion. Okay, so we can calculate the transport number of anion by using the formula current carried by the anion by total current. Okay, as we know, current carried by the anion is directly proportional to the speed of ions. So we are writing the formula transport number of anion or negative ion is equals to mu minus by mu plus mu minus. Mu is nothing but speed of anion. Here mu plus mu minus indicates the total current carried by the ions. And you can see I'm adding both the transport number of anion and cation. I'm getting this formula. Mu plus by mu plus mu minus is nothing but transport number of cation plus mu minus by mu plus mu minus. This is the transport number of anion. By adding this both, I'll get this formula. Mu plus mu minus by mu plus mu minus. So finally we'll get 1 as answer. This is nothing but transport number of anion and cation is equals to the unity. That is nothing but sum of the transport number of both anion and cation is always equals to the unity. Let's see the determination of transport number. So we know that transport number is directly proportional to the speeds of the ions. So transport number ratio here, T plus by T minus is equals to mu plus by mu minus. I'm considering this as equation 1. So mu plus by mu minus is equal to speed of cation by speed of anion. We know already. So from this what we can write, speed of cation indicates a fall in concentration at anode. So if all cations are moving towards cathode, there is a decrease in the concentration takes place at anode. So speed of cation resembles that fall in concentration at anode by speed of anion is nothing but fall in concentration at cathode. So I'm considering this as equation 2. From equation 1 and 2 what we can write, T plus by T minus is equals to fall in concentration at anode by fall in concentration around cathode. Okay, so for cation we can calculate the transport number by using this formula. T plus T plus T minus, transport number of cation is equals to falling concentration around anode by total falling concentration around anode and cathode. So T plus indicates falling concentration around anode. So this is the total transport number. So total falling concentration at cathode and anode. For T minus, for anion, we can calculate by using this formula. T minus by T plus T minus is equals to falling concentration around cathode by total falling concentration around anode and cathode. In terms of gram equivalent weights, we can calculate the transport number by using this formula. T plus is equals to number of gram equivalent weights, gram equivalents lost from the anode compartment by total number of gram equivalents lost from both cathode and anode compartment. So total falling concentration around in anode is nothing but gram equivalents lost from anode compartment. By total falling concentration is equals to number of gram equivalent weights lost from anode and cathode compartment. So in this way we can calculate the transport number by using these formulas. Okay, thank you so much for watching.